Okay, now here's your chance to find these standard normal probabilities. I was going to say we got some of each kind here, a less than, a couple greater thans, and these are betweens. And when you get to the last one, you may have a question. So if you're not sure what to do, just start the video back up again and we'll go ahead and look at these. Okay, so now let's see how you did. So this first one is a less than probability. That's the first case. That's kind of the simplest case here. So we got a 0 in the center. This is a negative, so it's on this side, and it's pretty far out because it's close to 2 there. And then I want the area to the left of, or less than. So you can use that as an arrow pointing that direction, so I shade that side of negative 1.89. Okay, so now for this one, I just look it up on the negative side. So negative 1.89, and I get 0.0294. So this area is 0.0294, and that is the probability I'm looking for. Just like that. So that's the answer to the first one. So now here we have a greater than probability, and so I'm going to draw my curve. 0 there in the center. Now that's a 3, so we know that's way out in the tail, like this, 3.04. That's a greater than sign, so the arrow is pointing this direction, so I'm going to shade this side. And really there's only a little smidget of area there. Okay, so now I'm going to look up 3.04 on the positive side of my table. So 3.04 gives me 0.9988. So remember, the table always gives you the area to the left of, okay? And what I want is this little smidget of area over here in the tail. So what we have to do is subtract from 1. And when I do that, I get 0.0012. And that is this probability. So very small chance, a fraction of 1%, that it's going to be above a 3.04. Okay. So this is another case too, another greater than. Okay. And this is a negative this time, and it's very close to 0. So maybe like this, negative 0.07. And I want this area up above. So it's going to be a little more than 50% of the area, right? Because from 0 on up is 50% of the area. So to find this area, I look up negative 0.07. And I look it up on the negative side. And in order to do that, I got to look up down here. I got to go all the way to the very bottom row, negative 0.0 and then 0.07. And where those two intersect, we get our area. And it is 0.4721, 4721. That kind of helps you. Instead of thinking of it as 0.4721, oftentimes when I see these, I'll think of them as two-digit numbers, 4721, and then for some reason that's easier for me to remember. So okay, so now I want this area up above, so I take 1 minus 0.4721. So 1 minus 0.4721, and I get 0.57 or 0.5279 is what I get, and that's this area, 0.5279. That's the probability. Like I said, a little more than 50%. Okay. So now we have a between probability. This is the third case. Okay. In this case, we have a negative and a positive. So the negative 1.14, and then the positive, that's pretty close to 0, 0.65. And I want the area between these two, right? Okay, so now this is the third case. So I look up both z-scores and I subtract the two areas. So I look up 0.65 on the positive, 0.65, and I get 74. Oops. Let me look it up again. 7422. So 0.7422. And now I look up negative 1.14. So negative 1.1, and then 0.04, and I get this. I get 1271. Like that. And so now to get the area between, I take the 7422 and subtract the 0.1271. So 0.7422 minus 0.1271. And I get, looks like I get 0.6151. It's hard for me to see the lighting. It's a little hard for me to see. 0.6151. And that will be the area between the two. Okay? Now this is another between one. And this one you probably had a problem. Let's see what it is. So this is negative, kind of close to 0, negative 0.34. And this one is really extreme, like way out in the tail, 3.76, right? And you want to find the area between these two. Okay? Well, we got to look up both z-scores and subtract the area. And this is where you had the problem, because if you look up 3.76 on your table, you don't find it, right? Positive 3.49, that's as high as you can go. And you get like 0.9998. And so you cannot go, or you cannot look up this on your table. The highest value you can look up is 3.49. So you can see down here what you do in this case. It says for z-scores greater than 3.49, you're going to use 0.9999. And the idea here is that you're using the largest number that you can use to 4 decimal places without just being 1. Okay? And so that's what you're going to use. So you may want to write that on the table, okay, as a reminder. So this one is like 0.9999. Okay, so now I look up this one, negative 0.3, negative 0.34, and I get 3669. Just double check here. Yeah. Oh, 3669. Okay. Is what it is. I thought something wasn't quite right. Okay. So now I just take the 0.9999 and I subtract 0.3669. And I get 0.9999 minus 0.3669. And I get 0.63 So 0.6330 if you had it to 4 decimal places. Okay, so those are the 3 cases for using the standard normal probability table. And they're going to form the foundation for everything else. And by the way, before I forget here, I should also show you, what if your z-score is way over on this end and it's less than 3.49, okay? So the highest or the smallest or the largest negative number that you can get is negative 3.49, which is right here, and that's like 0.0002. And so what you do in that case is for z-scores that are less than negative 3.49, you are going to use 0.0001 and then do the same thing, subtract the 2 areas. Okay, so that is a standard normal table. So in the next set of videos, you're going to learn how to use this table backwards. So we're going to have to use it both ways.